they get into the food through a few different ways. One is through the environment. So we know a lot of plastic and also microplastics are washing into oceans and rivers where different seafood can ingest them. It's also getting into the food. Like, I really think it's really important that everyone remembers that it's not just seafood that has microplastics in them. I think that they get a bit of a bad rap often due to their close connection to the ocean. It's also in salt, rice and vegetables. Lots of alcohol has found microplastics in it. Anything really that can be eaten could have microplastics on it or in it because there's so much already in our environment. So like there's microplastics in the air, there's microplastics in the dust. And so, of course, if you're using a plastic chopping board to cut up your food, you can imagine that knife is slicing up little bits of plastic, little bits of microplastic are then maybe getting into your food. So it's getting there through a whole range of different sources.
There's been a lot of talk about microplastics recently. I thought we would check in with a specialist in the area and see what they have to say. So today we've got Nina Wootton. So Nina Wootton is a postdoctorate researcher and a marine scientist. So she has dedicated her life to microplastics. So today we're going to look at what are microplastics, where do they come from, and what can we do to reduce our intake of microplastics? So stay tuned and we've got a lot to cover.
Thank you so much for joining us, Nina.
Thanks for having me, Cathy.
Look, let's just share a little bit about you and what brought you into this world of marine biology and microplastics.
Okay, that's a good question to start with, I guess. So I am a marine scientist at the University of Adelaide. In terms of my background, I actually grew up on a farm in Western Victoria, so I'm a big farm girl. Very much inland though, so I wasn't always as in touch or I would say obsessed with the ocean as what I am now. But I've always loved being outdoors and I always loved animals and especially had this huge passion for science. I guess I would call myself like quite a curious person. But yeah, when I first went to uni, I was actually studying to become a vet, mostly because I love animals. But I quickly realized that, I was way more passionate about some of these sort of big science questions to do with the environment and the ecology of the environment. And that led me into a marine ecology sort of career. I did a science undergrad degree and then eventually did a PhD in microplastics in seafood. And I guess over time, I started to see how the human impacts, like plastic pollution, are affecting the ecosystems that I have always cared so much about. So it kind of evolved into a broader interest of contaminants more broadly, particularly microplastics and how they're moving around the environment and into the food chain of different things that we're eating as humans. Yeah, that's really, I guess, my background.
Yeah, thank you. So just to give a bit of an understanding for everybody, what are microplastics?
So microplastics are tiny plastic particles, so anything less than 5 millimeters in size, which I think an easy way to think of this is, depending on how big your hands are, about half the size of your baby fingernail. Right. And they can come in so many different forms. So asking what are microplastics is like quite a hard question because they cover lots of different things. So they can come from, we call them primary microplastics, and they're things that are manufactured to be this size. So that's things like microbeads in cosmetics that you might use on face washes. Right. And also glitter is a big primary microplastic. Also, we have these things called nurdles, which are like the building blocks of plastic.
Right.
Sorry, I interrupted you.
No, that's okay. You said face washes.
Yeah.
So even those have microplastics.
Well, they used to. A lot of countries still have microbeads in some of their cosmetics, but I'm sure I used these plastics, face washes when I was younger. They have that kind of gritty bead in it. It makes you feel like you're exfoliating your face. They're microbeads, but they're pretty much not used anymore.
Okay. great.
There's the primary microplastics that I was talking about then, but we also, the main microplastics that people know about are secondary microplastics. So they're things that were once big bits of plastic and have been broken down into smaller pieces. So like imagine a plastic bag in the ocean, it's getting broken up by the waves and the sun, and eventually it turns into these little bits of plastic, and microplastics are pretty much now everywhere, I would say, pervasive.
Okay, and I suppose that leads us to the question of how do these get into our food?
So they get into the food through a few different ways. One is through the environment. So we know a lot of plastic and also microplastics are washing into oceans and rivers, where different seafood can ingest them. It's also getting into the food. It's like, I really think it's really important that everyone remembers that it's not just seafood that has microplastics in them. I think that they get a bit of a bad rap often due to their close connection to the ocean. It's also in salt, rice and vegetables. Lots of alcohol has found microplastics in it. Anything that can, anything really that can be eaten could have microplastics on it or in it because there's so much already in our environment. So like there's microplastics in the air, there's microplastics in the dust. And so of course, if you're using a plastic chopping board to cut up your food, you can imagine that knife is slicing up little bits of plastic, little bits of microplastic are then maybe getting into your food. There's potential sometimes with different cooking spoons that you use. Like I always try to use a wooden spoon instead of like a silicone coated spoon, because that they can, as things are heated, that's when they're more likely to release microplastic. Yeah.
Okay, so that's something else to think about, I suppose, the heat component.
Definitely.
Yeah. Okay. And with these microplastics, you talked about them being in vegetables and even alcohol. So how do they end up being in our vegetables or just things that we eat every day? I mean, fish, I can, because fish would eat parts of the microplastics, but this other area that they're just in everything. How do they get in everything?
I think the best way to think about this would be to think about the supply chain of where your vegetables first come from and how they end up on your plate. So obviously there's potentially microplastics. I would say not potentially. There's definitely microplastics in the soil that they're probably grown in. So it starts off there, but then also in the water that they're fed to help them grow. And then as they move from, they're picked and obviously put, depending on what vegetable or fruit we're talking about here, harvested and transported, often in plastic. And then they're taken to the supermarket where they're sometimes wrapped in plastic before you buy it, or they might be open to the air at the supermarket where there's microplastics in the air. So they could settle on it from that angle. And then also, if you decide to use a plastic bag to pick up your fruit and veg and then take that home, that is a huge source as well. So those plastic produce bags that you're collecting your fruit and veg in. And that is like a huge thing that people can do to help reduce it, is get some of those reusable non-plastic produce bags. And not only is that helping us use less plastic, but also it's helping the plastic not get into your food.
Wow. Okay.
Yeah. And wash your stuff before you eat it.
Wash everything before you eat it. But then even then, if we have microplastics in our water, that's is pretty hard to avoid.
Yeah, although you can get quite good filters now on your tap, which will help with also other contaminants like PFAS. I don't know how much you or your listeners know about PFAS, but that's another nasty chemical.
So tell us a little bit about PFAS.
So PFAS is one of these chemicals that we call them persistent organic pollutants. So they're pretty much persistent across the environment. Once they're in there, it's really, really hard to get rid of them. And they're not really used anymore. Like, we're not really allowed to use them anymore. They're banned pretty much across the board. They used to be used in a lot of like non-stick cookware. And also things like firefighting foams. They were used in lots of different ways. This is quite a while ago. We've banned them now, but they're still in the environment and they're definitely in our water sources. So I actually work with a PFAS expert here at the uni who's trying to work on degrading the PFAS using light. It's really cool. Yeah, but they have said to me, put a water filter on your tap the levels of PFAS that is potentially getting into our drinking water is
Wow.
above what we would want to be consuming.
Wow. Okay. That's some good advice.
Yeah. And there's a bit more, there's a bit more research out there on what PFAS actually can do to people, while the microplastic stuff's a bit unknown. So yeah, I think it's well recognised that we shouldn't have PFAS in our diets.
Yeah. Okay. Am I right in understanding that you helped create one of the manuals on how to measure microplastics in Australia?
Yes, that was a very fun project. Well, maybe not so fun, but very satisfying project that I've worked on for the last couple of years. So we worked with 40 other researchers from all over Australia and also internationally to get together some guidelines on how to sample microplastics in biota. It's mostly coastal and marine species because I am a marine scientist when it comes down to it. But in biota, water, sediment, and really the untouched one that we don't know much about yet is air. So how to sample microplastics in the air that we're breathing.
Right.
And yeah, I won't bore you with the standardization of these things, but everyone was using lots of different methods. And when you're using different methods, it's really hard to compare, in short.
So if you could summarize, how do we measure microplastics in different foods or the air or water or?
Okay. It's a hard question for me to answer, Cathy, because it's been a long time that I've been working on this.
Summarize a year's work into.
Yeah, I'll give a crash course on how to sample microplastics.
Okay.
So obviously, depending on what you're trying to sample, so if it's like biota, air, sediment, water, collect the sample is the first thing, and make sure when you're.
Could you just explain biota?
Okay, biota is any animals. That's it, really. Any animal, any marine living, not just marine, any living organism.
Right.
Is biota.
Okay. Thank you.
So yeah, that's like kind of an encompassing word. It's like fish. What we typically sample for microplastics would be like fish, mussels, oysters, seafood, animals, birds. Different. This is not just from a human consumption perspective. Obviously, we're talking about figuring out how much microplastics are actually in our environment. But yeah, you collect the sample. So it could be that water, sediment, biota, any living thing, or air. And then once you've collected it, you have to be really careful when you're collecting it to not use any plastic to collect it. Because, of course, if there's plastic in the things that you're sampling, then you're probably potentially getting plastic contamination from whatever you're using to collect it.
Yeah, right. Okay.
So that's a hard one. And then there's it gets kind of confusing depending on what sample you have, but we do a range of different things in the lab. Different chemistry, different chemicals will help digest. So like imagine if we took out a fish gut to see how much microplastic that fish was eating, we would digest it in a particular chemical so it would become liquidated. Right. And then you can use things called density separation, which is when you allow the microplastics to float to the surface, because microplastics are different densities in water, so they can, or in liquids, so sometimes they can float and sometimes they can sink. So we get the microplastics to all float, and this is a scientific thing which I'm not going to bore you with how you do that, but then you scoop it off the top using special filter paper. We filter it, and then we look at it under the microscope to identify the different pieces of plastic, and there's also a range of steps afterwards that we can do to verify what type of plastic it was. So you might find a piece of microplastic that matches the synthetic jumper that, you were wearing or whatever. Obviously, then that would be contamination. But you can match the microplastics to the source. So it might be that you find some Glad wrap that you can associate that it's like, Glad wrap brand, the type of polymer it is, and helps give you some details on origin.
Wow.
Really. Sorry, that was a lot of detail on sampling microplastics, but
no, that's really good. It gives us a really good understanding of the process. And I guess following on from that, if you can analyze what types of plastics, can you then see, okay, where are the majority of these plastics coming from?
Yeah, that's a good question. In theory, yes, you should be able to see that some plastics are coming from not necessarily like origin, like countries of origin, but like the source is in like what it's made of. So we get a lot of fibers in our samples, and a fiber is, imagine, like what I was saying before, your jumper, like a thin kind of thread almost that's come off your jumper, but they can get really, really small. So they're like tiny. I think that there's a paper out there that says around 1 million pieces of microplastic enter the wastewater system and then potentially the ocean for every load of washing. Yeah.
Wow.
So fibers are super common. Super, super common. That's like by far the most common type of microplastic we find.
Okay, I'm just going to jump ahead here. And how can we, I mean, we all do washing. So how can we reduce this? How can we reduce the number of fibers? If we're producing 1 million for every load of washing, I mean, I have kids, we do a lot of washing.
Yeah.
What can we do to reduce this?
I think there's 3 main things that I usually tell people to do. The first one is just try to buy non-plastic clothing. So I'm non-synthetics. I'm talking cotton, I'm talking wool. Because if you wash them and they go out into the environment, it's okay because they will break down. They're not synthetic. So that's like the number one best thing you can do. Also try to wash your clothes a little bit less, but I know it's hard with kids, and I can't imagine like if you had a teenage boy and those school shirts do manage to hold a stink, I would say. So you do want to wash things, but if you can avoid washing as often, that's always good. The second thing to do is you can get a filter for your washing machine. That's probably one of the best things you can do is put a filter on your outflow pipe. There is we do have quite good wastewater treatment. Hopefully in Australia. There's some questions around some areas, but most of the time it's pretty good. So they should get some of that microplastics out as well when they're during the wastewater treatment process, which is a whole other thing. And the third thing you can do, and this is actually probably my favorite one to do, is that you can buy these things called coral balls, like coral, like CORAL, like a coral reef ball. Yep. And you just put them in the loader washing with your stuff, and they'll, I don't think they by no means will collect all 1 million pieces. They'll collect a portion of them, but they kind of attract the microplastics onto its surface. So when you finish the load, you can take it out and peel the bits of plastic off and put it into your bin, which will then, of course, go to landfill, but it's better than going straight into the ocean. Yes,
definitely. Yeah. Okay, all right. Well, those are some good tips. So we know we've got a lot of these microplastics and a bit of an understanding of where they're coming from. What do we know about the health risks of them?
So it's still really early days in some of this microplastic health research. I think there's quite a few studies that have come out recently showing that we definitely are finding microplastics in humans. So, there's studies finding them in the heart, in our gut contents, in our breast milk, in testicles. Like they're finding them in different organs, but then the link to saying what there's microplastic in this organ and what effect is it causing is still relatively unknown. There are a couple of papers that were showing potentially risk of heart disease, but I think that it's just such a novel area that we're still really trying to figure out, and it's really hard. We can't do experimental studies on people and feed them microplastics till they start to have some health effect. Like that is so unethical. So obviously figuring out the effects has to kind of happen from natural occurrence So figuring that stuff out is hard, but there are some kind of ideas that we can link towards studies that we've done on other animals that show there is potential issues with reproduction, disrupting different cells and triggering inflammation and this sort of thing. So there's definitely early stages showing there are going to be human health effects. So what level, we just don't really know yet.
Yeah, and that's pretty scary. I don't imagine that the amount of microplastics is going down at the moment. Is this something that's still increasing?
It's just going to keep going up, unfortunately. Yeah.
Okay, so I guess watching what happens to humans and even animals, we might find out when the levels are quite high.
Yeah, exactly.
Okay. Are there any populations that are more at risk than others? I mean, how do we go in Australia versus, US or other parts of the world?
I guess in terms of populations, this is a bit of an unknown as well, because in terms of, we know that there's potentially like vulnerable groups to other environmental contaminants in general, like children and pregnant women are particularly vulnerable.
Okay.
First Nations people, we know that
Yes.
there's linkages potentially in other areas that they are more affected by contaminants or other health impacts. So we could infer a bit that maybe there could be more of an effect in those groups. But yeah, we don't really know a lot about it. I think it's important that we do more precautionary research. Like, we need to understand just what effect it's having in the first place, and then we can probably start to compare different groups.
Yeah, right. Okay. And do you think that fish is still the main concern, or do you think we just need to be careful of everything?
Yeah, I seafood's definitely a concern, but it's just not the only one. Like, we're seeing plastic in bottled water, soft drinks, like a lot of processed foods. A good tip I would say, it's probably the same as a lot of the stuff that you're trying to promote, Cathy, actually. The less processing they go through, the more likely they are to have less plastic. Because all those stages of processing are causing more microplastic potentially to be exposed to something. And it's honestly a systemic issue. It's how we package, store, and then also distribute food. It's like walk up and down a supermarket aisle. Like, plastic is everywhere.
It's all plastic. It's all plastic. Even you go to the fruit and veg section, you've got your plastic bags and or even the pick and mix section, it's in plastic.
So imagine the thin plastic bag that you collect your fruit and veg in when you're at the supermarket. That's so easily degradable because it's so thin and fine, and it would so easily break down. I think what we really need to do is try to go back to what they used to do back in the olden days, and use paper. Why can't we? Whenever I go to, my supermarket's really good. There's lots of paper options around. If you don't have your reusable cotton mesh bags or whatever you use to get your produce in, get the mushroom bag. Use that.
Yeah, go to the mushroom section. Yes, I do that sometimes if I forget. I'll just go to the someone gave me that tip, and I thought, that's a good idea.
Who cares? Like, it's there. It's ready to be used. And then, like, in my bulk food section in my supermarket, there are paper bags available. So I always try to use that. But
yeah, and I suppose even the, going back to how we used to eat. When it was less processed, probably how we used to dress. I don't know if we want to touch on clothing, because I feel like today fashion is, there's a lot of throwaway fashion, and they're not necessarily these organic fibres. These are synthetic fibres. Do you feel that has an impact?
Oh, fast fashion is one of the biggest problems of that's going back to that argument we were having, the discussion we were having before about the washing and how 1 million pieces per each load of washing. That's obviously awful. The washing loads going out, but there's so much fast fashion clothing that probably doesn't even ever get washed because people buy it and throw it out.
Yeah, wow.
And then it sits in landfill. Try to buy good quality stuff is my recommendation. I know it's hard with kids and they're growing and that sort of thing, but like, if you can buy something that can last for 10 years, that is so much better than something that's going to last for a few months.
And that's how we used to shop. That's how, you'd save up, you'd buy something that was probably locally made with organic fibres, and then you'd hang on to it. Whereas now I think, things are becoming so cheap that people have these options that just weren't available, and perhaps just don't realise the impact that it has perhaps on them, and perhaps it has on the environment as well. And with these fibres, do they transfer onto your skin? Is that also an issue?
It's actually a good question. That's actually a nice story. I had this, I don't think so very much from clothing will it permeate our skin. Like, obviously it could sit on our skin unless you're like licking your arm. I don't
Okay.
think it's going to get into your system. They're
So
not.
maybe toddlers.
Yeah,
Toddlers who
maybe.
chew their clothes, yeah.
And it is like probably an important thing to say in this is that some microplastic exposure is probably going to cause no problems. Like it will just pass through. It's when it builds up and builds up to have high levels of accumulation that I think we should start to be a bit more worried. So don't feel like you have to fret over any tiny bit of microplastic. Like it's not like other contaminants where they're actually going to really damage you initially. It's more the accumulation that's going to cause a problem.
Yep.
I would say. But anyway, the story I had this really lovely I think they were like a year 11 boy actually, and they were doing a project at school about, they had to design a science project, and they played a lot of hockey on those artificial turfs. And
Yeah.
he was noticing that at the end of the hockey game, like all over his skin, there was all this artificial bits of turf really. So they're all
Yep.
microplastics, and he was finding
Yeah,
them like,
okay.
they were like all over his skin, and like his mum was obviously getting frustrated because like then he'd go have a shower and it would all get in the shower, and he got a bit worried about how we might be exposed to that. So he came in and did some sampling in our lab, and he sampled a range of different students. He looked at their nasal cavity and also their tongue. He took like a mouth swab to see what microplastics they might be consuming from there, and he found microplastics for sure coming from those artificial
Wow.
turfs. So just
Wow.
another source.
Okay.
Not to mean,
Yeah,
don't,
and
like, I mean,
these-
there's so many benefits to playing outdoor sport. I don't think I'm suggesting that people should not play sport, but it's just think
Yeah.
about that a little bit as a way to hopefully combat. We need to fight organisations to have less plastic in general.
Yeah, and you think, you're going out and playing sport, you're being healthy, you're doing the right thing. You don't think that you're going to come home being, that little bit extra, with those little bit extra microplastics, do you? It's not really something that you think of.
Yeah, exactly.
So what can people do? So what are some of the steps that we can take to reduce plastics in our food and the environment? What are some key things we can do?
So I guess I think I've touched on a few of these things throughout, but I might just,
What's your-
reconfirm.
Nina's top tips.
My top tips.
Yeah.
The main one we can really do is reduce using single-use plastics. So especially in plastic packaging, just try your hardest. It's now not just about the environment, it's also about you as a consumer. So if that initially hasn't motivated you, the environmental impact that plastic is having, now think about it as a microplastic consumption thing, and hopefully that will motivate you to use less plastic. Put your filter on your tap. That's probably relatively easy. I know that I have a filter on our tap. They're not that hard to find. Go and do that. If you're storing food, try to get some containers that are glass or stainless steel. These are easy things. And the final thing, I guess, is rinsing your products prior to eating them.
Yeah.
So these are like the top tips for people who want to get less exposure to microplastics. Of course, there's lots of other top tips if you want to have less plastic in the environment in general, but I can talk about that after.
Yeah. Okay. And it's great for consumers to be really aware of this. What about sort of industry, retailers, food producers? Are there any tips for them or anything that perhaps they could be doing to reduce microplastics in the food that we all eat?
Oh, for sure. Like that. Here's my continuous argument I have, especially from higher level food producers, this sort of thing. You need to have less plastic entering our food system from the packaging and processing and transport. But it's also really hard, and I work a lot with the seafood industry because in this matter in particular, plastic is amazing at the same time. Like it is a great way to keep things fresh. It really seals in a lot of the... So, like, we can't get rid of plastic altogether because it's helping to keep our stuff food safe, right? So, I don't think we need to get rid of it altogether, but there could be, like, less usage where we can. I guess producers can try to shift towards using alternative materials that aren't plastic. I'm already working with potentially the seafood industry to hopefully use some materials that might be maybe not as long lasting, but they are made of cotton or more natural materials that they can use rather than having to use plastic in every, like they're still going to use it, but in every step of the food chain, supply chain.
Right.
And yeah, that's like, I mean, in terms of policymakers, I'm pro plastic tax. I think that we should make the producers pay, because they're the ones that are making the stuff and benefiting from it. So why aren't they paying for all the effort we have to do to clean it up and keep our bodies safe from it?
Okay, and I suppose that's really where you will see change, is if you impact their bottom lines, then I suppose that's when perhaps you are going to get a bit more reaction from them, aren't you?
Oh yeah, for sure.
Yeah. So are there any sort of innovations coming along? Is there anything happening in this area that you see that's quite exciting?
I mean, science is quite innovative in a lot of ways. So there are definitely like some bits and pieces of innovation going on. Like, you know, many years ago we didn't have these filters that could catch the microfibers from washing machines, or you know, there was nothing happening in this space. So we're definitely more aware of what it was, what the microplastic problem was and is. So there are solutions that are coming alongside that. Like I think there's like a new kind of edible potential plastics. I don't really know that much about some of these things, to be honest. I work more on the other end of like identifying the microplastics, but I think there are definitely like improvements in some of that reusable, compostable, biodegradable plastic. There is problems with those different types of plastic, I would say, as well. So use it cautiously. But there's definitely innovations. At least we're thinking about things, right? We're trying to be more creative and innovative with some of these different ways we can package our food.
Yeah, right. So what's your hope if Nina could have, you know, this is what the ideal world would look like? What would that be for you?
Oh, that's a hard question. I think
just in terms of microplastics.
I think that like my hope is that we all move towards using a lot less plastic, because that obviously overall will limit our microplastics. Although there's still a need for it in things like health. I understand it's so important, and there is definitely a need for it. But if we in general stop using the items that we don't need, like the single-use things, then hopefully we do have a space for that stuff that we actually need to be able to be used. I mean, I have a lot of hope in general about the plastic thing, because I think people are so passionate about it, and I see students and communities and even industry, to be honest, like wanting to be part of the solution. And because of that, the science is moving quickly, and collaboration in this space is really growing. So it's not something to be too down about. Yeah, exactly. Like we've seen changes before. Like I remember, I think it was back in like 2015 when that first video came out. I'm sure a lot of people have seen it. It's this video of this turtle, and it had a plastic straw stuck in its nose. Yeah. Have you seen that video?
Yes, I have. Yeah.
It went really viral on social media. Yeah. This is like kind of when social media was just coming up. So interesting to see how that played out. But that viral video of the straw being removed from the turtle's nose was absolutely essential in the ban of plastic straws that we have now across a lot of Australia and also internationally. And also, even if places don't have plastic straws banned, consumers now know to make a choice about using a straw. So they might ask for an alternate, or they might just choose not to use one. So I think that kind of stuff gives me so much hope, because that was 10 years ago, and since 2015 we have had so much growth in the plastic space in terms of awareness and people trying to make a difference. So there's always space for more, but I feel positive about it in general.
Yeah, it sounds like there's definitely hope. And if people want to follow you or learn more about microplastics and what they can do, is there somewhere that they can follow you or look at your work, or what can we do?
So I have a couple of social media accounts at the moment. Both of them are actually via Instagram. So I run this project up in the Northern Territory in Arnhem Land, working with Indigenous communities about teaching them about marine debris and plastic pollution, and how we need to limit our plastic use, and helping them do beach cleans up there. And that project's called Toys for Turtles. We do a lot of recycling as well, localized recycling solutions. So that has an Instagram. It's at Toys for Turtles.
Toys for Turtles.
Toys for Turtles. Yep. Maybe you can put it in the show notes or something.
Yeah, great. Yep.
And then I also have just recently launched a podcast of my own with my colleague, Professor Bronwyn Galanders. And that's more about marine science broadly. So we do have an episode on plastic pollution, but it's at a much higher level probably than what we discussed today. But we have lots of other really interesting episodes on different things that are happening in our marine environment. The algae bloom is obviously a big one at the moment for those who are in South Australia. So we have an episode on that. And you can follow that. It's called Ocean Pod, and we have an Instagram. It's called literally @OceanPod.
At Ocean Pod.
Okay. So you can follow that, or just find it on Spotify or Apple Podcasts. And otherwise, if you want to read some of the science that we've talked about today, if you just Google my name, Nina Wootton, Microplastics, pretty much all my papers are open access, so everyone should be able to read them and find out about microplastics in seafood in particular. But also those field manuals are there, and there's lots of stuff you can find.
Brilliant. Great. Thank you so much for your time, and not just for your time today, but thank you for all the work that you're doing in this area. I think that we've definitely got a long way to go, but it's great to hear that there is hope and there are things happening. So it's not all doom and gloom.
I always try to say we have hope. Never give up.
Always hope.
Yeah. There's
so many, as you said, with the straws. Look what we've done with the straws, and that's amazing. So
exactly.
Great. Thank you so much for your time, Nina.
No worries,
it's been
Cathy.
Fantastic talking to you, and wish you all the best in your future projects, and keep us up to date with any new findings or any new projects.
Cool. Thanks, Cathy.
Just a reminder, guys, that we do have our Goodnessly app. So if you are looking at supporting your health and you're wanting to understand what is in the food that you eat, things like additives, sugar, if you're interested in perhaps organic ingredients, if any of these sort of align with your values, then please download our app. You can create a free account, and it'll make your shopping and clean eating a lot easier. Thanks, guys.